let's play with fractions a bit more. We've learned about different ways to represent fractions by drawing out what a fraction means, mostly based on the idea of an equal part of a whole. For example, 1/3. I could draw myself, say, a cake, nice square to the best of my ability, and split that cake up into thirds. So maybe about here is 1/3, and there's another third somewhere in there. So here's my thirds, best of my artistic ability at the moment. And then I want to represent one of those thirds. So maybe I'll pick the middle one here. So that section right there is my 1/3. And I could compare that with, say, a half or a fourth, some other different fraction, different denominator, different way of splitting something up. And it's nice to have equal size wholes, otherwise it's hard to compare. So I'm going to draw my best equal sized whole. And this time I'm going to choose to split it vertically to help differentiate some more. So here's my quarters. And again, I just want one of those. So maybe I'll pick this one right here. And as far as comparing them goes, it looks like a third is a little bit bigger. And the way to compare these two is to find a common denominator. And we also looked at a little mathematical way to do that too. And the common denominator, the graphical way to do that is to draw each, cut each like the other to make them comparable. So to compare, we're going to cut each like the other. So the one that's in thirds, I'm going to cut vertically into fourths. And the one that's in fourths, I'll cut horizontally to match the thirds. So right around here and here-ish, about. And then if I count up, I have a grid on each of these that's 4 by 3. And so there's 12 pieces in each. So I've rewritten each of these as 12ths because they're a 3 by 4 grid. I have 12 equal sized pieces. In the first one, my 1/3, there are 1, 2, 3, 4 of those 12ths. And in the second one, there are 1, 2, 3 of those 12ths. And clearly 3/4 is more, 4/12 is more than 3/12. And a shortcut that we looked at before for that comparison when we want to try and figure out which fraction is bigger, the first fraction or the second fraction, is an idea of cross multiplying these, where I can multiply the 4 up and the 3 up. 4 times 1 is 4, 3 times 1 is 3. And one thing the cross multiplication kind of misses out on is the fact that that 4 what? And if we do this across the bottom idea, 3 times 4 is 12ths, then that kind of matches the picture that is 4/12 and this is 3/12 there. And we can use this idea of comparison to take this even farther. When we talked about comparison a while back with whole numbers, that was a subtraction problem. So how much bigger is 1/3 than 1/4? We can answer that question. And what would happen if we combined 1/3 and 1/4? We can also use the same scenario to answer that question. So for example, somebody says, well, addition ought to be easy. What is 1/3 plus 1/4? And the problem is the denominator is a description. Here I have one thing, but that thing is a third. Here I have another thing, and that thing is a fourth. So you can't just say you have two what? 2 pieces, but they're not the same size. So that's a problem. This idea of comparing with a common denominator means 1/3 is really 4/12, and 1/4 is 3/12. So combined, I can now say, well, clearly I have 7 pieces. They're all the same size. How big are they? They are 12ths. I have 7/12. Common denominator is essential to do addition and also for subtraction. A subtraction is a comparison. So if somebody asked how much bigger is 1/3, than 1/4, well, that's the subtraction problem. What is 1/3 minus 1/4? Well, we know that 1/3 is 4/12, and we know that 1/4 is 3/12. And we're just talking about 12ths here. 4 of them minus 3 of them leaves me 1 of them. And I can pretty clearly see that in the picture. This one has 1, 2, 3. It has a 4th one that this one does not have. So there's that difference here of 1/12. 1/3 is 1/12 more than 1/4. So these pictures stemming from what does it mean to be a fraction basically tell us how we have to add and how we have to subtract. And the bottom line is you got to have a common denominator. Otherwise, can't do it. Big question now is, how do we find common denominators? Coming soon.